Hey everyone, my name is Valerin. In today's video, we are going to have a look at how you can use the GPT-4 Omni API in order to better use the OpenAI latest and greatest model. We're going to have a look at how you can do some simple prompts, how you can do some streaming, how can you request outputs as JSONs, and in the end of part of the tutorial, I'm going to show you how you can input some images and even how you can use or create a basic agent-like tool that is using custom functions that the LLM is actually going to call for you. Let's get started. If you want to follow along, there is a completely free text tutorial on the mlexpert.io blog, and here within the GPT-4o end-to-end multimodal model by OpenAI blog post, you can find the complete text tutorial along with all of the code that I'm going to show you in this video. Also, please join the mlexpert.io Pro membership where you can access the complete bootcamp that is available on mlexpert.io. Thank you. The GPT-4o model has already appeared on the LMSYS Chatbot Arena Leaderboard, and as you can see, currently this model is the best performer of them all. It is beating the older GPT-4 models along with Turbo 1, and you can see that the actual difference right here in the Arena ELO is quite large compared to models such as Gemini 1.5 Pro and Quad 3 Opus. It looks like the GPT-4o model is truly, at least according to this leaderboard, the best performing model that we currently have. I have a Google Colab notebook that is containing the code that we are going to use for trying out the OpenAI model, GPT-4o. And in here, you can see that I'm installing just two dependencies. First, I'm going to install the OpenAI library, which is allowing us to make the calls to the API. And then I'm also installing the TikToken library, which is essentially a way for us to use the tokenizer or the encoder as they call it for the text. So we are going to be able to compute some of the input tokens required that we are going to send to the API. Next, I'm also going to download a simple image that I'm going to show you in a bit. And for the setup, the more important parts right here is that I'm setting my OpenAI API key. So if you don't have this, you need to get one. Of course, this is going to be using some credits for your account since the model is not free to use. Then I'm going to specify an overall model name. Then I'm going to specify a seed, which I'm going to try to essentially reproduce the results that we get. And then I'm going to initialize the client, which is also going to be the OpenAI client that we're going to be using. Then I'm adding a simple helper function that is going to be using throughout the output of the text, since the output is going to be a bit longer than I want to. So how do you call the API with the new model? It's actually relatively simple, and it is one-for-one and compatible with the previous API calls. You are essentially getting these messages, and in these messages you can specify a role. And in this case, I'm specifying a system prompt with a role of system and then a user message. And both of those objects do have to have a content. So for the system message here, I'm saying that you're Dwight K. Schrute from the TV show The Office. And then in the user content part, I am asking the GPT-4o to explain how GPT-4 works. The actual call itself is going to be needing the model name that we're going to be using, the messages. This is the actual payload that you are going to send, a seed phrase, which is not required. This is our effort to have or some of the reproducible results. And then a temperature, again, an effort to have reproducible results. I'm not really certain that this is going to work 100% of the time, but please let me know in the comments below if you have a better way to see it or have some reproducible results as an output. All right, so the temperature is a very small value. As you can see, it's not 0. Let me know down in the comments why I'm not using 0 and just a small number. And this is the output time. I would say that this is very slow compared to what I've seen thus far. But again, this is a lot of text that we got from the model, and this is the response. It's a bit hard to read, but here we have an ID choices, which is essentially containing the text that was generated, then a timestamp of when this was generated, the model name, which is the exact model with the particular deployment or checkpoint from OpenAI, system fingerprint, and then we are going to be having this completion usage, which I'm going to show you in a bit. So here is what this looks like. The answers or the prompts that were calculated for this usage. So you have prompt 30 tokens, completion 434, which is essentially the time, most of the time where the output was slowed down, and then the calculation of both of these. So GPT-4o has 128K context window, so we are nowhere near that, and it is twice as fast, at least according to OpenAI, as GPT-4 Turbo. So I can say relatively confidently that this model is indeed pretty fast, and it is somewhat comparable to GPT 3.5 Turbo in terms of speed. And here is the output of the 434 tokens. One of the important parts for GPT-4o is that this new model is also using a new tokenizer, which is essentially saving a lot of tokens, especially for non-English languages. But in our case, we're going to be using primarily English. But if you're using this new model, of course, your output of the English language is going to be relatively cheaper still. And on top of that, if you're using other languages, probably you're going to be having a lot of reduction in your usage as well. So this is the output. It is pretty well formatted. I've tried this with GPT-4 Turbo, and with this model, the results are quite different actually. And I would really say that I would like the GPT-4o formatting and the way that it writes compared to even to GPT-4 Turbo. And it looks like that this model is performing very well. I'm not really sure how it works under the hood. Probably it is a smaller model in the number of parameters, or they just put on a lot of more compute to this model, but it appears to be working very fast. It is interesting whether or not this is using some mixture of experts or sparse mixture of experts architecture in order to significantly improve the performance on top of GPT-4 Turbo, but it is end-to-end trained new model, so I'm not sure about that. So in order to count the input tokens, I'm going to be using the tick token library that we've installed previously, and then you are going to be needing to represent or pass in the model name that you want. And in this case, this is the encoding O200K base. So this is essentially a representation of the new tokenizer that OpenAI has. And here I'm adding a helper function count tokens in text. And this is what the function does, is to just encode the complete text with the encoder. And then I'm going to essentially calculate the number of tokens using the length function, the built-in length function. And as you can see, this is essentially 13 tokens from this text, which is the original system prompt that we've passed in. Then if you have a much, let's say, harder structure to calculate, you can see that in this case, I'm passing in the messages, and this is pretty much taken from the OpenAI cookbook, in which those constants are specified, at least for GPT-4 and GPT-4 Turbo. I'm not exactly sure if this is correct, since the examples didn't actually include the GPT-4o, at least at the time of this video, but it appears that this calculation for 30 tokens appears to be equal to the one for the prompt used here, which should give you a relatively, if not correct, relatively similarly correct number for the count of tokens in the messages. Next, if you want to stream the response, you just need to pass in stream equal to true. And then on the chunks of the completion, you can iterate over those. And this is essentially pretty much the same output with some difference, unfortunately, even though I've set the seed and the temperature. and this is going to be outputted as a stream. And you can essentially use this if you're building, for example, a chat application and you don't want to wait for the complete response. So in order to simulate a chat, you need to essentially extend the messages structure with a row of an user and an assistant. So if you want to simulate part of the chat, these are pretty much the same two messages that we wanted. And then I'm going to essentially inject something that the assistant has told us, which is, of course, not real. But if you specify the role as an assistant, you can essentially simulate the chat from the assistant. And you can see that nothing to worry about. This is what I'm saying right here. GPT is not that good. For open LLMs are vastly superior. And then on top of this message, you can ask which open LLMs should I use that is better than GPT-4. And essentially you need to redo the request. This time around, you can see that we are getting twice as fast response, but of course this is thanks to the much smaller output. And here it looks like that the suggestions are of very old LLMs. It is suggesting BERT, Roberta T5, GPT-5, GPT new, which are, I would say, very, very old. Not mention anything about Mistral or Llama or anything like that. Very interesting. All right, so if you want to get a JSON response, here is something that I've passed in. Write JSON list of each employee under your management, include a comparison of their paycheck to yours. Essentially what you need to do to get a JSON or only a JSON response, you can specify this response format parameter. And here you need to specify type equal to JSON object. The only other option, at least of now, is to specify text, which is the default. But if you specify the JSON object type, you can get similar response to this one. This is the structure that the model has created for us. Jim Halpert, sales representative, less than Dwight's. Phyllis, less than Dwight's. Stanley, less than Dwight's. And then Ryan Howard, temp, significantly less than Dwight's. All right, so this is great. Okay, so if you want to pass in some vision data, you can also work with images. And this is the image that I'm going to pass in to the model in a bit. You can see that this is Dwight K. Schrute from future Dwight. And this is writing to Dwight in the present, some would say. And you can see the message right here. Do not drink the coffee. It's really important, etc. And what you can do to pass in to GPT-4o this image in particular, well, the documentation says that you need to create a base64 encoding, and this is how you can do this. Essentially, you open the image file from the image path, then encode the image with the helper library from Python, and then after that, you need to essentially construct this type of URL, and this works for JPEG images. Of course, you can be smarter than that and detect the image type and probably change this, but in our case, we have a JPEG image. So in order to make the request, I'm going to essentially keep the system prompt as it is. And then for the user content, you can see that actually now I'm passing in an array. And the first element of the array is the text that I want to prompt the model. What is the main takeaway from the document? Who is the author? And then I'm specifying image URL. And then I'm going to be essentially calling our helper function right here. So this is the way that you can specify the messages. And the rest of the code is pretty much the same. And you can see that the response time on this image is quite fast. Of course, you need to consider how these models are pricing the images as tokens as well. And this is explained in the documentation. But yeah, the response is quite fast. And the model says that the main takeaway from the document is warning that someone will poison the office coffee at 8 a.m. and instructs to not drink the coffee. The author of the document is future Dwight, which is really impressive. I mean, The document is quite nice. The print is quite nice, but even though the OCR appears to be working quite well under the hood, if this is doing OCR step on top of the document, maybe not really sure. But the model is able to reason quite well just from the image without any retrieval or without any parsing of the image whatsoever. So yeah, this appears to be working quite nice. At least, of course, this is a very simple document, but even that, it appears to be doing some magic, if you will. The final part that I'm going to show you is actually pretty important because these types of models can do or use tools which are essentially calling functions. And this is pretty much extending the LLM capabilities a lot. So in order to show you how you can do that and probably have use this as a base, for example, you can build your own agents or two user LLMs with those type of functions. I'm going to show you in this case that you can create an API call function and allow the LLM, or in this case GPT-4o model, to call this function as you are describing the parameters of the function and what is the output of it. So this is a standard function that I'm going to write in. This is actually using the officefly.dev API. And here you can get some quotes from season and episode. And then I'm also filtering out the quotes from a specific character. And I'm also imposing a limit on the number of quotes that I'm going to fetch in. And then at the end, I'm just essentially concatenating everything with two new lines. So this is a string or a text that is going to be returned. And for example, if I get quotes from season 3, episode 2, then for character Jim, and I limit that to 5. So these are all the possible characters that I've chose to support. You can see that we're getting some quotes from the API. And essentially, this is going to be now passed in as a tool to the LLM. You can see that to specify the tools, I'm going to specify a type of function, the function name, and this is essentially the description or the documentation of the function. You also need to specify the parameters, and you can see that the properties of those are actually the arguments of the function. So the season, type integer, show season, episode, show episode, character, type string, and the enum possible values are the ones that we've specified right here. And then I'm also going to specify that we want, or the required parameters are season, episode, and character. Of course, this is quite verbose, specifying all of those, but throughout reflection or other means using Python, you can probably write something a lot better. And this is essentially how the tools below LangChain and Crew AI are actually working under the hood. So this is pretty much standardized version of the model, how you can specify your tools. Then I'm going to essentially want the model to list the funniest 3 quotes from Jill Hubbard from episode 4 of season 3. So in order to call this with the tools, I'm going to also specify the tools that it can use. In our case, just a single tool. And I want this tool choice to be created or given by the LLM. So if you call the model, you are essentially going to get tool call. And in this tool call, you are going to see something like this. So you need to call the function with season 3, episode 4, character Jim. The name of the function is get quotes. And I'm going to specify the available functions. Essentially, this is a mapping. And I'm going to append the message to the current messages. So I'm going to simulate a chat. And then in order to call the function, I'm going to just get the function name, get the function itself based on the name from the mapping. Of course, you can have more than one function. Then I'm going to load the arguments in a dictionary using from JSON, since this is essentially a JSON output. And then I'm going to call the function with the double star method, which is essentially going to specify or use the dictionary parameters in order to call the function. and this is the response that we get. So these are essentially all of the available quotes, or at least the 20. Yeah, I think that it was 20 by default. Yeah, the 20 quotes that we're going to specify for the LLM. Then I'm going to pass in to the messages the response with the ID of the call, the tool that we got, the function name, and the response of the function. Finally, you need to create another call, which is going to be including this response from the tool. And this is essentially how you get your final response. So this is essentially the output. You can see that it is ranking. That's where you're wrong in your project. I'm your project supervisor today, and I have decided that we're not doing anything until you get the chips that you require. So I think we should get some now, please. So this is essentially the first one right here. Hi, this is Mike from the West Side Market. Okay, let's see. Yeah, this one is the second one, etc. So it did the ranking for us according to at least to GPT-4o, how funny it is. And then it applied another text on the end of it. So this is it for this video. Now you know how you can call the GPT-4o API, and you know how to pass in some messages, how you can even pass images, and how you can use GPT-4o for function calling. This is essentially the base of how you can build your own agents from scratch if you want to. Thanks for watching, guys. Please like, share, and subscribe. Also join the Discord channel that I'm going to link down into the description, and I'm going to see you in the next one. Bye.